Hello, good morning, everyone. We start today our lecture on fundamentals of machine learning and connectionist modeling. And I will provide a brief overview of what we are going to see during this components of the course, which is very important component of the course. I will post this lecture a few hours after we finish the lecture. And I will go over a brief overview of the origin of machine learning to differentiate between machine learning and pattern recognition, which many of you are familiar, I suppose a number of you are familiar with. And then we will lead to the need for more powerful type of machine learning, which leads us to the discussion about deep learning, which we are going to tackle in details in a few weeks from now. So I'm recording this lecture, and I will be happy to respond to any of your questions. Simply let me know, and I will be happy to respond to you. So first of all, I would like to mention that I will set up components of the course known as tutorial. And I will assign a time for it, possibly in the late evening. I have asked our department to give us a slot where one of my TAs will go with you over some tutorials to help you out with certain type of tools that we are going to see during this course, and to support you in a number of your assignments and problems that you are going to encounter in this course. So that's one component. The second part is I have created a team for ECE457B. It has a number of sections, and these sections, I mean, you will be able to discuss or send me feedback, or to my TAs feedback about those. So for now, we have the section on general aspects of the course, on tutorials, on the assignments, and also on the quizzes. I will add the topic on tutorials as soon as I get the details from the department officials about the time that we are going to have these tutorials. The tutorials as well will be recorded and will be posted as well for the course. So let's start talking about machine learning and the origin of machine learning. So as I mentioned during the last lecture, that machine learning helps us quite a bit in mimicking the behavior and mimicking the capabilities of human beings in going over a certain type of decision-making processes. Given a certain type of environment, given a certain type of tasks to be accomplished, machine learning should help us out making decision, and the decision could be either classification components or archiving of a particular theme of a text, or differentiating between one set of components to another set of components given certain set of features known as clustering. So we would like to do this type of implement this type of capabilities that are similar to what human beings are able to do. And this is very important component, and this particular task in a human is dictated by how to perceive a particular pattern or object in a particular environment. And this environment could be noisy, this environment could be noisy, it could be with sounds, it could be with the visual type of noise, it could be, I mean, it depends on the perception channel for that particular pattern. I mean, it could be speech, it could be utterance, it could be vision. And humans have always strived to impart machines with similar capabilities as theirs for faster task execution. And we are going to see later part of this course that machine learning by itself, machine learning, I mean, as a set of algorithms, is not able to mimic the higher level capabilities of a human cognition, and we are going to see that. But machine learning is able and has been able over the past several years of providing classification predictability at a very, very high level of accuracy. And we are going to see how this has evolved over the years during these sets of slides. So we are going to use the modern tools of artificial intelligence and machine learning to be able to impart capabilities of the human being into a machine. And that's the spirit of machine learning that we are going to see during this set of lecture. So reason for the hugely growing role of machine learning and artificial intelligence is mostly dictated by tremendous opportunities for economic development. And as we can see from this small statistics, according to Deloitte and PricewaterhouseCoopers, the GDP will set to grow globally by up to 14% by 2030, which is almost $16 trillion to the global GDP. This, I mean, was almost unthinkable only 5 to 6 years ago. And people are even expecting that the growth might even reach to 20%, which is around the $20 trillion contribution to the global GDP. So, and this is according to how things have been developing and how have been evolving in the field of AI and machine learning over the past several years. AI machine learning are transforming the world, and this is a fact. And how this is happening, I mean, mostly because of the accessibility to a huge amount of data and accessibility to powerful algorithms. Let me note here that many of these algorithms haven't been developed very recently. Some of these algorithms, especially in the field of deep learning, which we are seeing it now as in an explosive growth, has been developed in the mid-90s, early 90s, mid-90s, and has only come to fruition and implementation over the past decade, actually. So we have access to a large amount of data. Quite a bit of it is labeled, processed, and we have accessibility to cloud computational powerful tools of computational systems, and also powerful computers, namely computers with a large number of GPU or even with single GPU. The machine today that you have, I mean, in a laptop, powerful laptop, equates almost the power of 10 PC computers of 10 years ago, almost, in terms of power, in terms of memory, and in terms of execution. I mean, this has led to the usage of machine learning in a wide range of areas, not only by large companies, but also by small companies and even by individuals. So we have the big data and we have the tools, which are the software, and this has led to tremendous growth in several areas of innovation and technology, namely Internet of Things, autonomous vehicles, 3D printing, 5G networks, smart grid, energy storage systems, biotechnology, nanotechnology, fintech, and the list goes on and on and on, where scientists and innovators have been making usage of the big data that have been generated by these type of technologies. And the tools of AI and machine learning has helped in extracting knowledge from these various type of technologies. So basically it is a feedback loop. Data is generated from innovative type of technologies, data is labeled, data is utilized, is processed, and machine learning, AI, is providing further knowledge, and the knowledge is being transmitted back to these type of development and these type of technologies to improve them even further. So we can see a feedback loop here to helping out with the transformation of the world as we are seeing it nowadays. So let me provide very brief definition of what we mean by AI, what we mean by machine learning and deep learning, in order for us to be within the context of this type of definition throughout this course. A lot of textbooks, a lot of websites provide similar definitions, or slightly different definitions depending on the context of what is being discussed in that particular theme. And the most general definition is what we know as AI. So AI has been there since the early 1950s, and it's a term that was coined by John McCarthy in the late 50s. And AI, it was defined by a number of scientists that have met in the 50s and defined it as the effort to automate intellectual tasks that are normally performed by humans. So basically, it's to design machines that are intelligent enough to automate intellectual tasks. I mean, at that particular time, the bar was set too high, I mean, for achieving artificial intelligence, and people thought that AI was going to solve all type of problems that a human has been accommodated to utilize and in much faster time. But this has been proven to be a little bit difficult to achieve, as we are going to see in the next set of slides. Machine learning is a subset of artificial intelligence, and is an algorithm or a set of algorithms that are meant to discover data representation rules or models, or we call them also knowledge, for prediction and classification. So that's the very, very general type of definition of machine learning. I will provide a little bit more generic definition of machine learning in the form of tasks, in the form of experiment, and in the form of repetitive type of tasks for improving the experiment and improving the outcome. Deep learning is a new connotation that has come up over the past 3 decades. Some of these type of connotation have related to improvements of neural network systems in the late 80s, early 90s. And deep learning at that time was related to developing connectionist model structure that has several type of layers of processing. And nowadays it came to denote a special type of machine learning algorithms. So it's a set of machine learning algorithms which involve hierarchical and multi-layered data representations. So neural network, possibly in the 90s or the early 2000s, could have been called deep learning. But a number of specifications, as we are going to see them either later today or early in the next lecture, deep learning is a little bit different from the notion of the conventional neural network. And we are going to see the main difference between what we mean by deep learning in this context and what we meant by deep learning in the early 2000s and the late 1990s. And so AI is the superset, which includes machine learning, which in turn includes deep learning. So deep learning is a subset of machine learning, which is itself a subset of artificial intelligence. And artificial intelligence, of course, includes a wider range of areas that we are not going to go into this course, but they include multi-agent systems, it includes expert systems, it includes fuzzy logic systems, it includes machine learning, and the whole range of computational tools that are meant to automate the intellectual tasks and extract knowledge from experiments or from data. So this is another representation. So I took this picture from a website which is mentioned down below there. So you can see the overall picture of artificial intelligence. And as I mentioned to you, I mean, from the 1950s to the 1980s, people thought that they are going to solve the problems of the world, I mean, by developing artificial intelligence tools. So this is the early artificial intelligence era from the 50s to the 80s. It continues up to this day, but there was a lot of excitement at that time. And then artificial intelligence is going to encompass a set of tools, and here, as we are seeing it, is encompassing the machine learning tools, which we are going to discuss a little bit more. And then deep learning, of course, is a subset of machine learning. So I would like to give you an overview of what is what we are talking about here when we speak about machine learning, when we speak about deep learning. Please note that fuzzy logic systems, which we are going to tackle in the later part of this course, is not part of these components. I mean, artificial intelligence, although computational intelligence includes artificial intelligence as part of it, and artificial intelligence in a certain way, when we are talking about expert systems, about knowledge-based system using fuzzy rules, could contain in itself, I mean, fuzzy logic systems. So we can even integrate the fuzzy logic systems as part of artificial intelligence, since it contains the concept of expert system, and we will talk about that in the later part of the course. So let's put it, I mean, to summarize, artificial intelligence is a whole superset of computational tools that are meant to automate the extraction of knowledge given a particular type of experiments or given a particular set of data. That's the summary of it. Machine learning is a subset of these supersets, and deep learning is even a subset of machine learning. We spoke about this type of recent breakthroughs that were accomplished using tools of artificial intelligence, and namely tools of deep learning. So we spoke about the Synapse project that was created by the IBM scientists, and it continues to be improved. I mean, the number of 10 to the power 9 artificial neurons has been exceeded 1.5 years to 2 years ago, and now they are talking about achieving 1 trillion artificial neurons within this particular system, and 10 to the power almost 18 synapses for this particular system. This is extremely huge, and this is an experiment that is still going on with IBM researchers. So they would like to mimic the behavior of the human memory on very, very small scale. Google DeepMind, many of you are familiar with it, and it has made several type of breakthroughs over the past few years. One of them is the 2016 breakthrough, and DeepMind has been recently, which is the project of Google's, has been recently being able to solve one of the major biological type of problem for a certain set of sequencing of certain DNA structure, and this has been mentioned in the news only two weeks ago. I might speak about this a little bit later when I speak about deep neural network and some of the major achievements. The IBM as well, Watson, has been one of the major discoveries and major accomplishment using the most recent tools of natural language understanding and machine learning technologies, namely deep learning type of tools. As I mentioned also in my last lecture, Amazon, Google, and Netflix, and Microsoft, Facebook, to name few. I speak about the giants that many of you are familiar with or have spent some time working with them over the past few years as a co-op student. They have been developing type of technology that were not existent only 7-8 years ago. So these type of technologies that these giant companies are developing are very recent. Some of them are only a few months ago, some of them are a few years ago. So we are seeing the major contribution that deep learning systems are making in the world, and we are going to speak as we proceed in this course and on the application and implementation. So this part picture denotes two major discoveries that have been made in the 40s and the 50s. The von Neumann computer, which is the sequential computer, which is the type of laptop, which is the type of desktop, which is even the type of large computer system, and the Rosenblatt perceptron, which represents the early perceptron system, the artificial neural networks, machine learning using connectionist models, and the deep learning tools. And so we have two major type of discoveries, and both of them, the von Neumann computer was seen the light immediately after World War II. The Rosenblatt perceptron also has its origin in the work of McCullough-Pitt in 1946, 1947. But Rosenblatt was the first person who created the original perceptron system in the 50s, and he improved it after that to become the father of connections modeling, or neural network as we know them today, or deep learning as we hear of them nowadays. What is the notion of pattern that we are going to target and we are going to discuss in this course? So we are going to speak about patterns, we are going to speak about digital objects, if you would like to call them, because these patterns that we are speaking about today, they could be a speech signal, they could be a handwritten words or digits, they could be a human face, it could be a DNA sequence, or it could be weather information. And all of them are provided to us through type of sensory signals that we are applying them to a number of processes or to objects around us, whether it's a speech signal, hearing, a speech sound from others or from a computer or from a machine, how to digitize it, how to make it usable by a computational system. And this pattern could be any abstract entity that describe a physical object within our particular type of environments. And major discoveries that have been made over the past few years have tackled many of these particular aspects. When we speak of speech signal, we talk about natural speech understanding that have been developed now by the major innovative firms, handwritten words or digits. They are becoming almost perfect nowadays and used by banks. It's used for authentication of people, for authentication of users of a particular type of device. A human face for detecting people, for recognizing the emotion of a person. DNA sequence in the area of biological type of systems for diagnosing particular type of disease, or even pre-diagnosing diseases, whether a person is holds particular disease that hasn't expressed itself yet, and then you can prepare medication to prevent that particular disease to completely come to the open. Weather information, how to tackle particular weather information before a major type of hurricane or a typhoon comes to land, how to prepare for it from a particular set of signals that we received the day before. And all of these type of systems are, we call them pattern, because they could be digitized and they could be taken as an information that will serve the users to implement them for a particular engine. Most of these type of engines are known as machine learning type of tools. Pattern recognition, so we spoke about pattern, now we speak about pattern recognition. We hear a lot about pattern recognition. Pattern recognition has been an area that has been developed since the early 70s. Even before that, in the 60s, people have been talking about pattern recognition, but not in the formal way of the generic representation. So it was connotation used by computer scientists at the early day of pattern recognition systems in the late 60s, early 70s. Pattern recognition is the study of how machines observe the environments. So how to take a look at the environments and how to observe it and provide us with information about that particular environment. Learn to distinguish patterns of interest, how to classify or how to cluster set of patterns for which they are not labeled. We will talk about the difference between classification and clustering later on. How to make correct decisions about the categories of the patterns. So pattern recognition provides us also with means for making decisions about the classes of patterns that we are tackling or that we are handling. Pattern recognition involves theory, algorithms, and systems that can assign patterns into category. So more theoretically inclined versus machine learning, which is more practically oriented. As I mentioned, pattern recognition has seen the day in the early 70s as a formal set of algorithms, theoretically built using certain mathematical type of tools at that particular time to solve, ideally, a certain type of problem. But there were a number of issues with the pattern recognition systems, which I am going to highlight them after these slides or the next two slides. Pattern recognition applications, I mean, they have been used in the 80s, they have been used in the 90s for license plate recognition to help police for certain type of tasks, for fingerprint recognitions to archive and to classify or to authenticate people with a certain type of fingerprint signature, to detect a certain number of disease, I mean, based on certain type of imaging or computer vision type of systems, or to help robot systems to do autonomous navigation. So pattern recognition has been utilized in the 70s, in the 80s, and in the 90s. But pattern recognition comes with a number of difficulties. They have a number of challenges, which I am going to discuss them in order for us to separate between pattern recognition, what we mean by pattern recognition, and what we mean by machine learning. Although in a number of context, people, I mean, speak about pattern recognition or machine learning in the same way, but they are different. They are two different type of technologies. Each one of them has their own advantages, and pattern recognitions, as I mentioned to you, they are morely theoretical framework that have been used to solve a number of problems using a certain set of techniques in the area of image processing, in the area of computer vision, or in the area of signal processing. And I will mention some of these difficulties and why they have not been very, very powerful tools that have been utilized in the past few years. So continuing with the pattern recognition algorithms, we noted that for pattern recognition, it has been used for continuous model, which we call it regression models. We will speak about regression models and about classification model later on. But let me summarize very, very briefly what we mean by regression and what we mean by classification. So when we speak by regression, it means that we are developing a model for which the outcome is a continuous signal. It's a continuous information. A very simple example is how to create a model of a curve that is predicting what is occurring tomorrow in terms of the weather, once we know about the humidity, once we know about pluviometry, once we know about temperature. So it is based on previous type of data that have been collected, and it provides us with the continuous model. So a continuous model, imagine it as a continuous curve. It's a prediction, and it's a particular type of curve, which is completely contrasting with the discrete modeling, where the outcome of the model that we are designing is going to be a category. A category, which means that from a bunch of animals, you are going to classify whether this animal is a cat, whether this animal is a sitting dog, where this animal is an elephant, where this animal is a cow. So these are categories. So this is what we call discrete modeling. We'll talk about that later more, because in machine learning, we are going to tackle these two major aspects: the regression aspects, known as predictable modeling systems, and the classification, which is categorical type of modeling. So we are going to see all of that. Of course, going back to pattern recognition, we recognize that there were a lot of techniques. I mean, some of them are the least square, some of them are known as the ridge regression, some of them are known as the lasso approach. These type of approaches are still being used nowadays for a number of applications, but they are not very widely used, as we are going to see later on when we contrast them with machine learning. So going back to the algorithm, so we have the algorithm for regression and we have the algorithm for classification. So linear and quadratic discriminant analysis, LDA or QDA, is one particular tool, formal tool that has been developed in the 70s to solve a number of problems using classification. Decision trees, which are also utilized in machine learning and also utilized in the field of pattern recognition, they are still being utilized. The Rosenblatt perceptron is the earliest model for pattern recognition. Why is that? Because the Rosenblatt perceptron, which is the parents of neural networks and of deep learning, was a very simplistic type of model which provides us classification of a system that is true or false. And it is a pattern recognizer rather than a machine learning type of model. Although the Rosenblatt perceptron is going to be developed further, and it's going to be used later as the powerful tool that is utilized for developing deep learning type of techniques, as we are going to see it later. Support vector machine is also utilized in machine learning, as we are going to encounter later on, but it has been used as a pattern recognizer, especially in the 80s and in the 90s. And many of these type of techniques utilize in conjunction with these methods of classification or methods of regression with particular type of tools that are most used in the area of signal processing or in the area of computer vision or in the area of image processing systems. They are very useful, but they have been formally utilized to solve these particular type of problems. But as we are going to see later on the different type of issues, but let me give you prelude why pattern recognition hasn't been the winner in the context between pattern recognition and machine learning type of models. So let's look at the MNIST data set, which is the largest data set of digits for systems, and some of you may have utilized it in order to train a particular model to recognize digits. And the other one is known as the ImageNet, which is a database that has been created for animals, for flowers, for objects, and it has been utilized by people to train models in the field of pattern recognition. So as you can see from this particular picture, I mean the lower left-hand side, you can see that the number that is mentioned there could be a 0, and that number could be also 6. So this is, I mean, using pattern recognition type of techniques, using particular rigid type of rules for pattern recognition, the system is not able to decipher whether this is a 6 or whether this is a 0. Because for pattern recognition, you have a certain set of rules, similar to the decision tree type of system. And this type of rules are not based on trained data. It's not based on trained data. Rather, it is based on certain type of formal algorithmic implementation. So they don't look at the approximate level of whether a number belongs to 6 more than 0. There is a little bit of probability theory that is used in the area of pattern recognition, but most of the time, these type of tools in the area of pattern recognition used formal tools of whether signal processing, image processing, or speech type of processing signals. So these type of systems are not able to provide us with high level of accuracy whether a number belongs to, particular class 0 or particular class of 6, unless we train, quote unquote, train. So remember this word, this particular engine over several thousands of the number 6 or the number of 0. The same thing for the ImageNet, which is on the right-hand side. When you have an elephant in a particular type of situation, sitting elephant, or an elephant in an aggressive type of motion, or an elephant that is drinking, the system is not able to decipher that particular image. So the system has been possibly using a particular set of filter developed over, an image processing filter to say that if a certain set of the images are in this particular type of in this particular portion of the image, then this is a sitting elephant. If the elephant is in another particular type of posture, then you have to provide this posture. You have to provide the filters that are able to extract the information about that particular posture. So now, if we would like to decipher the image of an elephant in any particular type of posture, we have to present to the system all these type of features or attributes related to these particular images. And this is extremely difficult to do when we are tackling the pattern recognition system. So this is, I mean, the main challenge of the pattern recognition problems, and these are the challenges. So if we look at them one by one, we look at them, there is the wide variability of the same digits and objects. So if we look at the number 6 or at the number 0, we have thousands. I mean, even ourselves, when we write number 6, from one day to the next month, possibly we write the 6 under different type of, writing. The 0, the same times, whether we are in a hurry, whether we are in a certain type of environment, when we are writing that number. And this, if it is not included in the algorithm for the pattern recognition, then the system is not able to decipher number 6 or 0. So it becomes quite complicated to include all the version for this particular number, for this particular object to be recognized. The same thing for the elephants. If we would like to recognize an elephant or a dog or a cat in various positions or doing a certain type of actions, we have to feed the pattern recognizer with as many postures, with as many combinations as possible. Sometimes the combinations might become infinite number of positions or posture, and this minimizes the efficiency of this particular type of algorithm. So if we have large number of objects and each one of the objects has certain type of posture, has certain type of behavior for certain type of environments, then the pattern recognizer becomes extremely challenging algorithm to implement. And that's why the area of pattern recognition hasn't seen a huge growth after the 1990s, and people have to come up with particular type of tools to improve the capabilities of more advanced type of algorithms. Let's not be mistaken here, pattern recognition are still being utilized in a wide range of applications. However, these applications are constrained for a certain number of objects within a very well-structured environment. If you have structured environments, if you have only few possibilities of the object existing within that particular environment, then the system pattern recognition tools that have been developed in the 70s and the 80s are perfect, could serve perfectly to solve this problem. However, if you are dealing with the particular systems for which the major, version of that particular object are moving, like an animal moving within a certain type of environments, it's almost impossible to recognize or to classify that particular system in with a very high accurate level. And that's where machine learning and especially deep learning system have become the tool of expertise for classification of signals or classifications of animals. And the ImageNet dataset classification system has been the benchmark of excellence, which told people in the 2011-2012 that deep learning is indeed the tool to utilize for classification of a huge, large number of objects, despite the fact that this object might be noisy, they might operate in an unstructured type of environments. And then the machine learning type of tools, namely deep learning systems, have been able to do that. So the objective is to design a machine that learns pattern from data. Data is becoming available. Data is becoming versatile. Data is becoming archivable. So we can put them into large computers. Even a huge amount of data could be classified. And when we speak of data, we speak about images. And when we speak about images or signals, images have huge, contain, with the very high level of, very high level of definition of a particular image, you might need sometimes very large amount of computational power or memory to store one single image. And as you can see nowadays, I mean, phones, smartphones or whatever, are able to hold, I mean, thousands or millions of images in a very, very small memory, something that was not available only 10 years ago. Now computers are able to do that and are able to process and have access to these large type of memories. So we are going to see why machine learning has been growing and has been growing fast because of the convergence of three major things: the capability of computational systems, the availability of large amount of data, and the availability also of algorithms that are becoming more and more powerful. And that's why machine learning is becoming the tool of excellence for people to utilize and to implement for a large number of applications. Of course, we are going to look as well at some of the deficiencies of machine learning, why they are not also perfect systems. We are going to see that as well. So let's define, before that, any questions that I can answer you, please? If you have any questions, or so you can always email me and or my TAs, and they will be happy to answer your question even outside the lecture. But if you have a question, please feel free to let me know by sending text, or I try not to, I mean, to respond to you, but mostly I'm not focused on the chat, the meeting chat system to respond to you. But if you have small questions, please let me know, and I will be happy to respond to it as we speak during the lecture. So this has been an overview of the origin of computational systems based on various type of tools, the early onset of artificial intelligence. We spoke about the tools of pattern recognition, which have been very useful, and they are still being very useful in a wide range of areas, and they are utilized in everyday life now. And we saw as well that these type of tools might not satisfy us for a number of applications where we are tackling fast-changing environments, such as when we are driving. What type of cars? How distant is the car in front of us? What type of what is the status of the road in front of you by doing, I mean, certain type of analysis on the, the contact between the wheel of the car and the road. So there are some sensory systems that provide you with that particular capability, how to deal with that, how to implement that particular information to help us make a decision whether to accelerate, whether to decelerate for a car that is intelligent, or how to recognize a human from an animal in a particular type of setting, how to recognize a high number of fruits based on a sorting manufacturing cell to see which one is good to sort and which one has to be discarded, using computer vision type of approaches. So machine learning systems came, to life in the late 60s, early 70s, and people have started talking about machine learning at that particular time. And that's why the little bit of confusion between machine learning and pattern recognition, both of them have appeared almost during the same time. And even pattern recognition, a number of people are considering it as part of machine learning. Although I disagree a little bit with that, because machine learning, pattern recognition has its own type of tools that are anchored mostly in the field of computer science as developed in the 70s and the 80s. So it's a set of tools that were developed for recognizing a pattern using mostly image processing or computer vision. Machine learning is able to solve the problems that haven't been solved by pattern recognition by utilizing training of data, by utilizing type of tools. So machine learning basically is a tool that is helping to solve problems for which pattern recognition was not able to tackle utilizing its own tools. So in that particular regard, we see them as machine learning helping the tools of pattern recognition. And both of them, when they are combined in certain type of context, they become very, very powerful tools. Because as we are going to see later on, when we are going to tackle deep learning components of the course, we are going to see that some of the layers of a deep learning model, which is a machine learning type of model, are no other than filters that have been developed early on in the 70s by the tools of pattern recognition. So I like to see that these type of technologies complement each other. So while machine learning has on its own very, very good depth in terms of the utilization of techniques, but ultimately deep learning system is going to utilize certain tools of machine learning, but at the same time it makes uses of certain type of filters that were developed early on by scientists, computer scientists in the field of pattern recognition. So I don't want to reject pattern recognition or machine learning. I would like to see them as powerful tools that are helping us out solve a wide range of problems in the area of computer vision, in the area of natural language understanding, in the area of speech recognition, or in the area of manufacturing systems, autonomous robotic systems, as we have highlighted a number of these applications. So I would like to see them as a set of tools that people utilize them. And that's why I spent a little bit of time today telling you about the tools of pattern recognition and how they have a certain set of shortcomings in being implemented and being utilized for solving the wide range of problems when we are tackling objects or when we are tackling classification within complex environments. So we are utilizing this type of machine learning tools, which we are going to describe in this course, and mostly we are going to use the connections modeling tool, namely neural network, artificial neural network, perceptron systems, multi-layered perceptron systems, deep learning, convolutional neural network, and other type of approaches. So let's define very briefly here the notion of machine learning, and this is borrowed from a number of textbooks, including my textbook, and people agree that machine learning is an area of artificial intelligence that provides computers or computational machines with the ability to learn from data while discovering patterns. Why I say computers or computational machines? This particular definition is a little bit old, I mean, in the fact that we are utilizing computers, but computational machine is a little bit wider range, because nowadays we know that very, very small microprocessors with capabilities that surpass, I mean, many type of computers, especially GPU systems with certain set of interface. They are becoming very powerful type of systems, not necessarily having a screen or not necessarily having a certain set capabilities or keyboard, but they could be utilized as an engine. And I call them a device, computational type of device, computational type of systems. So let's put computers as the superset of all these type of computational tools systems. It could be a small PC, it could be a computer with several type of GPUs, or it could be a cloud computing engine with many type of distributed type of computational computing type of system. So let's put it as such. So it doesn't follow explicitly programmed instructions. Why I'm mentioning this in red? Because the red components is what pertains to pattern recognition. Pattern recognition is related to the implementation of algorithm in the sequential computer developed by von Neumann. It could be also applied to neural network, as we are going to see later. But this red statement here, it doesn't follow explicitly programmed instruction. So programmed instructions are no other than implementation of filters, implementation of formal type of algorithms that extract specific type of features from a particular type of objects using certain type of computational tools, merge them within a computational algorithm to provide you with a decision of a class. So this is what we have learned about the pattern recognition components. Machine learning is a little bit different from that. Machine learning utilizes data to improve itself. Machine learning utilizes tools such as neural networks, such as support vector machines or other type of tools that we are going to describe very shortly to make use of data that are presented to them. They are going to utilize a trained type of engines in order for it to provide you with an intelligent outcome. When we speak of an intelligent outcome, is an outcome that has come out following the mimicking behavior of how the brain works when it is trained over many type of objects over several periods. So that's what we want to define machine learning. So it's an artificial intelligence tool that provides computational system with the ability to learn from data. Presented to certain data, you have an engine that is going to extract that data, extract the features of that data, and the more you train the system, we are going to see the training processes for the system in few slides, the more the system becomes more powerful. This is completely different from the implementation of explicitly programmed instructions which relate to the pattern recognition. So I would like you to recognize this difference between pattern recognition in general and machine learning. So in a number of places, both of them are, they are utilized in the same manner, but there are quite a bit of differences. Both of them cooperate with each other, but I would like to differentiate them a little bit. And this course is about machine learning, utilizing these tools that I am going to discuss with you. So the machine learning is used in situations where it is very challenging or impossible to define heuristic manual rules, face detection, speech recognition, stock prediction. So one particular example that I can give you, there are many machine learning tools now that are able to recognize a face, recognize the feature of a face, whether a person is sad or happy or calm or whatever. It recognizes also, detect a face from a certain set of objects, not only the face detection, but the face recognition and the emotion recognition from the face. Why? Because the pattern recognition type of tools that have been developed, you have to present to the system the large number of possibilities that this face, how it looks like a face within a set of objects. But sometimes a face could be oriented in a certain type of direction. The face could be oriented, it could be noisy. Part of the face is occluded by certain other objects. And still, we would like the system to recognize it. So pattern recognition is not able to recognize that this is the face of a person if the face is hidden by 20% or 25% by another object, which could be another face or it could be another object. So we have to train an engine over hundreds of times, thousands of times, and sometimes millions of times on how the system is able to recognize a face in almost all circumstances. We don't need to have heuristic or manual rules. We don't have to have specific type of features for a particular system to let us know that this is a face or this is, a particular utterance of a human, how to recognize it in a certain type of environment. So these type of systems have started to become very required in the early 21st century when people started talking about developing speech recognizer for people to develop autonomous systems, autonomous cars, autonomous robots. So people have found a lot of difficulties utilizing the conventional pattern recognitions to get these type of innovation, these type of technologies developed. And that's what has led to the growth of deep learning systems that have become the tool of excellence for people who are innovating autonomous car systems or autonomous vehicle systems, natural language understanding systems, natural speech understanding, translation, intelligent robots, intelligent manufacturing systems. So these areas have seen huge growth over only the past 10 years, because there are now powerful tools, not so expensive to develop, to solve these type of problems. Face recognition, face detection, object detection, car detection in a highway, speed detection, how much speed, I mean, within a part of the highway, the onset of a disease, when we can say that we have a pandemic, how the disease is spread out. I mean, getting the data about the spread of a disease in a particular type of region before it becomes endemic, and later on a pandemic, similar to what we are seeing nowadays. So all of these type of tools did not used to be in the 10 years or 12 years before now. In the 2008, 2010, when I used to teach the area of artificial intelligence, teach the area of pattern recognition, even neural network, which I have been teaching for almost 26 years now. I mean, I never thought that neural network or the descendants of the original neural networks are able to solve one day the huge complex problem of speech recognition or object recognition in various type of environments. Because simply when I taught the neural network in the early days, neural networks are systems that are implemented on a very restricted memory of a small computer. It cannot accept large amount of data, it cannot be trained on a huge amount of data, and the system cannot deliver in real time. This has all been resolved to a large extent, at least for the past number of years. And many of the techniques that you are seeing nowadays in the area of obstacle avoidance of intelligent robots, in the area of autonomous navigation of cars or buses, in the area of self-driving cars, these systems wouldn't be available nowadays if it were not for the developments of and the powerful type of tools of machine learning, and specifically deep learning. We will come back to this type of description later on. It's deep learning that is making nowadays these powerful natural language understanding systems that are being developed by the giants in the technology. It is natural language understanding that is now being utilized, especially in the form of reinforcement learning, but in the deep learning type of contexts that is providing the success of companies such as DeepMind and or Google or Facebook or others or Netflix for suggestion, for proposition of what type of movie you are going to watch next or during a particular day of the week. All of these type of technologies were not to be developed if it were not for the major or the explosive growth of the implementation and the usage of the tools of machine learning, which we are speaking about now and which we are describing, and which I am going to talk later on about the deep learning, which is going to be the descendants of machine learning, if you would like to call it that way. Let's, make a very, very brief definition here for the machine learning algorithm. So this is coming from a number of textbooks. I mean, it's not my definition, but this is the conventional type of definition that people are utilizing. So in general, a machine learning algorithm improves some measures of performance. We are going to see the notion of performance later on, but this is generic. When executing some task T through some type of experience E. An example, the task T would be to assign a category of a fraud, not fraud, of credit card transaction. How can we assign a category of fraud, not frauds? The usage of credit cards, in various type of areas for certain type of transactions that has not seen, your card hasn't seen in the past, might flag it as a fraud. Or the transaction made by one particular person who has access to a number of credit cards information for the same type of transaction. This could flag it as fraudulent type of transaction. So this has to be trained over tens of thousands or hundreds of thousands of tasks, okay? Which is basically assigning a category of fraud, not fraud, for a particular credit card transaction. So this is an example whether a category is a fraud, not fraud. So in this particular system, the machine learning system is going to provide us with a discrete category, fraud or not fraud. So the outcome of the decision maker is a fraud or not fraud. And then if it is fraud, then possibly, I mean, the banking, I mean, officer or the banking clerk will call you, give you a call. Did you indeed make this particular type of transaction? We have certain type of issues. Our system has flagged it as fraudulent. Did you approve of this or not? And if you say it's approved, then it provides you with access to that particular that particular business. If not, then the credit card will block that particular transaction. So the performance measure is what we call the accuracy of the classifier. We are going to see several performance measures in this course, namely accuracy, namely precision. We are going to see the notion of recall. We are going to see the notion of F1 measure. They are very powerful performance measures. We are going to highlight them during the course of these in the future lecture. And these are extremely powerful type of performance measure, whether for categorical or for continuous type of prediction type of models. Training process. Training process E is how to set historical credit card training transactions. So this is several type of transactions that the system has archived, has utilized, and categorized as fraud or not fraud. And this type of transactions have been archived in the past. And the person who's developing this type of engines has had the information that if this type of transactions have occurred, most probably it has been a fraudulent type of transaction. So if a transaction is occurring, I mean, you have made a transaction, let's suppose, in Waterloo area today, and within 10 seconds, a transaction of your card has been made in another part of the world, okay? And with large amounts. So then, I mean, by doing this, the system is going to flag something. And by calling you and by recording that particular type of transaction, the system is going to label that transaction to say that this transaction has occurred in 2 different locations within 5 minutes time frame, has been fraudulent. So if you amass a large number of these type of transactions, then the system is going to understand that future transactions are most probably fraudulent. Okay, so this is what we call the training process. And we apply this machine learning algorithm to many other type of applications, such as animal recognition, such as detection of an environment of a car, such as the sorting of a particular fruit. A lot of things could be utilized, and we will provide a number of examples on this particular aspect. So I would like you to remember here that unlike pattern recognition, machine learning is utilizing experience, utilizing performance measure, and utilizing training data that are collected through the experience. So this is very, very important for the system. So we have the outcome of the system, whether it's categorical or not, such as the fraudulent or not fraudulent, the performance measure of the system, accuracy of the classifier over huge training type of data, and the training process of the system when you collect training transactions and you categorize them and you label that particular type of data. And we are going to see all these particular aspects, how to train a classifier system, how to optimize the training of a system, how to get the best possible type of model of a training system. So we are going to see all of these type of components when we are going to tackle the next stage. So this is also a picture that I took from one of the websites here. And I will mention all these type of websites in separate slides later on to give credit to all the people that have contributed to these type of slides. But I found these slides to be quite interesting. As you can see, there is the machine learning workflow. That's how the system is. So you take the left-hand sides of the components where you can see what is known as the training set of the system. So the training set of the system is the information that we have gathered from the experience. And this particular training could be supervised, which means that the data is labeled, the training type of set that you collected, all of it has an input and an output. value for the category, whether it's correct, it's fraudulent or not. And the unsupervised is when you have a whole set of data, but you don't have a system to tell you whether this is fraudulent or not. But using machine learning type of tools, we can cluster, or we can put a category for a set of the data that has been collected to belong to class 1, to belong to class 2, to belong to class n as a whole set, which we call it clustering. So one part is called the supervised, the other part is called the unsupervised. We'll come later on to this particular system. We continue to the part, which is what is known as the feature extraction, which is the the gray bag there, and the feature extraction. So what is the feature extraction? Feature extraction is no other than the information that you are going to input to that particular engine. The easiest feature extraction system of an object, it's an image. That could be the training set, so that's an image. And the image is formed by certain number of pixels. The pixels is given in matrix form if you have a black and white type of picture, but it could be three-dimensional type of image, RGB type of image. Each particular type of pixel at a particular location of the matrix of the image represents a feature. Okay, so the feature is no other than the elementary elements that represents the object, as simple as that. So a feature of an elephant, we could extract a feature of an elephant, or I can give you a feature of an elephant. You can give me immediately a feature of an elephant. Large ears, the elephant has large head, it has a trunk, it has tusks, it has big legs when compared to other animals, of course. So these are features. If that particular element, that particular animal has feet, sitting on 4 feet, has big heads, has big trunk and big tusk, then the system is we call it an elephant. So these are features, and we are going to see the type of features for an image, for a signal, for a particular type of system in general. And then you have the algorithm. So the algorithm is going to be the engine. So the engine is going to take the feature of the image or the object or the signal, and then is going to utilize it in its little engine, and it's going to generate whether a predictive model or a group of objects. So a group of objects, it's when you are dealing with the unsupervised systems, when the system is not labeled. Predictive model is when you have a continuous type of model, similar to the rental in a particular type of area. So you go to an engine that is located, in a commercial type of websites for renting in a particular area. If the area is close to University of Waterloo, if you have a number of 2 bedrooms, if you have a number of kitchens, if you have a number of washrooms within that area, then the system is going to provide you in an explicit way the price range between $1,000 to $1,200 per month. So these are continuous type of information. The predictive model also could be for classification purposes. You have a number of animals, and then the system, after it receives the features of each one particular animal, is going to tell you whether this animal is an elephant, whether this animal is a cow or is a cat, depending on the number of animals for a particular set of training system. And the grouping of objects, which is, we call it clustering, is object clustering on themselves. So if you have cats and you did not label them in the supervised system, then the system is going to cluster you all the type of cats that have been trained in the system. If you have a number of elephants in certain images, but you did not label them, then the system is going to recognize all the elephants sitting or standing as elephants. If you have dogs, or if you have a type of cars, the system is going to classify according to a particular type of cluster. So what happens here? So this system is generating these type of models. So once we create this engine, once we train this engine, then at the lower part of the picture, you see the new data there. we are going to present to the system that has been trained a particular set of information, an image often of a cow or an elephant. And then the system is going to automatically go to the engine and is using the predictive model or the clustering type of model is going to tell you whether that object is an elephant or a dog. So this, we are going to utilize it later on to create what is known as semi-supervised type of models, where we create the models using labeled data. Once we have the labeled data, then we can enrich that model with new data, which are going to be annotated data and labeled data that could be utilized later on by people for their training sets. And this is a big industry in a number of developing countries that are collecting large repository of images, objects, or things, and they are outsourced, basically, because the annotated data could go through a human after it goes through the engine. And this is going to increase the labeling number of the object, because labeling data is the most expensive data that you can get. And the large companies that we spoke earlier about, I mean, the large innovative companies, I mean, their major business model is to sell or to utilize their labeled data to create new algorithms, whether for speech recognition, whether for image recognition, for video recognition, for human recognition or face recognition, because they have a huge amount of data. And we say that this type of data are utilized by them, and they are utilized most of the time in semi-supervised type of system. So I'm going to stop here for today. I mean, I would like to continue on the machine learning systems, and I will speak about the various type of tools that are utilized in the machine learning field, namely the supervised, the unsupervised system, which I am going to teach you later on. We will speak about the other type of tools, the semi-supervised models, and also I will speak a little bit about reinforcement learning, which we are not going to tackle in this course. So next time I'm going to talk especially about the areas that we are going to tackle in the field of machine learning and where we are going to head within a few weeks from now. And I will also speak about the expectation for assignment 1 and assignment 2, which are going to be mostly in the field of machine learning and the applications. Even assignment 3 is going to have parts related to machine learning and part to fuzzy logic systems. The same thing for the 3 quizzes. One of them, the first one is going to be on machine learning, the second one on machine learning, the third one is going to be on a mix between machine learning and fuzzy logic system. So I will provide more details as we progress on this particular slides. So next time, I mean on Monday, I will continue with this set of slides. So we'll continue on this set of slides, and then we'll start talking about the origin of connectionist models, the earliest perceptron system, how it was created, how it was able to solve the pattern recognition model and the machine learning model, the Rosenblatt perceptron. We will speak about the difficulties of one single perceptron. We will talk later on about the multi-layer perceptron system, the connectionist modeling as part of machine learning, and then which is going to lead us later on to 2 or 3 models of deep learning models, which we are going to see alongside with the application and with implementation. So that's what I wanted to share with you today. So I will utilize the various channels of the team system. As I warned you, I mean, the assignments, so please make sure that the assignments, and I will mention this again and again, I would like them to be personally made. I would appreciate that each one of you tackle the assignments on your own. You could discuss on a certain aspects of the assignments. I can't prevent you from discussing the overall part of the assignments, but each student has to provide their own solution, their own library, and their own analysis of the assignment, because most of the assignments are going to contain analysis of the results and why the result has been as such, why the performance measure has been as such. So it's going to be an individual type of work. I will speak about that later on as we progress toward more on the machine learning type of material for the next week and the week after. I can take one or two questions before we leave if you have any. As I mentioned to you, you can always email me and my TAs. I will put the Piazza system. I mean, I will activate the Piazza system for our lectures and for our course later on, either today or tomorrow. And I will be happy to hear any feedback or any comments you might have. So if not, I will post this lecture today in a few hours from now on the same part of the lecture system. And I thank you again for attending today's lecture. And I will see you then on Monday at 10 a.m. Have a good day and have a good weekend. Bye.